Welcome. Today we're going to do lesson 1, 2. That's use segments and congruent. The big question here is what are congruent segments? So you should be able to answer that when we're done. So if you'll start by looking at your chapter 1 postulates and formulas frame, we're going to fill in the first part of this. So this frame is about all of the postulates and formulas we will learn and use in chapter 1. So we're going to have one spot to put all of those. The first main idea is postulate 1, and that's our ruler postulate. This is a pretty basic postulate, but let's look at it. So it says the points on a line can be matched 1 to 1 with the real numbers. The real number that corresponds to a point is the coordinate of the point. Pretty basic one, just saying we can make a number line. Okay, so here's a number line, and we can put points on that. And that point I just made coordinates with the number 1. So that's all that one is saying. The second part of it says the distance between points A and B. Written AB is the absolute value of the difference of the coordinates of A and B. So if you subtract two coordinates and take their absolute value, that gives you the distance. A key thing here to notice, we write distance like this. We use two capital endpoints. We don't put any sign above them. So that would be, this right here would be read the distance AB, the distance from A to B. Next key thing, or next main idea in this frame is postulate 2. This is called the segment addition postulate, another really basic one. It says that B is between A and C. So I'm going to draw a picture down here. So here's my A, here's my C, and I'm going to put a point B in the middle of them. If B is between A and C, then A plus B, or I'm sorry, then the distance AB plus the distance BC equals the distance AC. So it makes sense. Here's the distance AB. This would be the distance BC. And doesn't it make sense that AB plus BC would equal AC? Just kind of common sense. The next piece of this says if AB plus BC equals AC, then you know B is between A and C. So if we know that this distance plus this distance equals this distance, then you know B must be between A and C. So let's look at our notes now. Example 2, so we're skipping the first example from this lesson, is apply the segment addition postulate. It's about a road trip. The location shown lie in a straight line. Find the distance from the starting point to the destination. So here's my starting point, here's a rest area in the middle, and here's my destination. So from the things that we just looked at, we know if we add this distance, so 64, plus this distance, 87, that'll give us our total distance. So 64 plus 87 is 151, and that is miles. Let's look at the next example problem. Use the diagram to find the distance from K to L. So this right here is KL, and we know that you can say 15 plus the distance KL, and that has to equal my total, which is 38. So I just made a little equation here. If I subtract 15 from both sides, so I'm solving for the KL, the distance KL is 38 minus 15, which is 23. My extra example says find QS and PQ. So find the distance from Q to S and the distance from P to Q. So QS, we want to find this entire distance. That would be QS. And we've got two pieces of that. R is between them. So we know we can add QR plus RS. We can add those two distances to give us our distance QS. So I'm going to say 31 plus 30. Which is 61. So my distance from Q to S is 61. There's my first piece. The next one says find PQ, so I'm just going to change my color a little bit here. And if I want to find PQ, that's this little piece. Well, I know from P to R is 55. So in order to find PQ, I can write a little equation. I can say PQ, the distance from P to Q, plus 31, that has to equal 55, my total distance. So if I subtract 31 from both sides, then my distance, PQ, equals 55 minus 31, which is 24. My last example here says consider the points A, which is negative 2, 1, B, which is 4, negative 1. Should say C here, which is 3, 0, and D, which is 3, 5. Are segment AB and segment CD congruent? Well, to know if they're congruent or not, we have to look at their distances. So I added a little coordinate plane on mine. This isn't in your notes. You should probably just sketch one on your notes. So let's start by graphing these points. The point A is negative 2, negative 1, so I'm going to start at 0, 0. I'm going to go back 2 to the left 2, so negative 2, and then I'm going to go down 1, negative 1. There's my point A. Point B is 4, 1, so if I start at 0, 0 again, I'm going to go positive 4, so 1, 2, 3, 4 in the x direction, and negative 1 in the y direction. So here's B. If I draw my line segment AB, then I can find the distance AB just by counting the spaces. There's 1, 2, 3, 4, 5, 6 spaces, so the distance from A to B is 6. Let's look at our other 2 points, our segment CD. Point C is at 3, 0, so if I start at 0, 0, I'm going to go to the right 3, 1, 2, 3, and up 0, so I'm going to put my point right here, and that's my C. D is at 3, 5, so again I start at 0, 0, I go to the right 3, 1, 2, 3, and up 5, 1, 2, 3, 4, 5, and here's my point D. So right here is segment CD. Now I want to find the distance CD, so I'm going to count the spaces. 1, 2, 3, 4, 5. So my distance from C to D is 5, and my distance from A to B is 6. Is 5 equal to 6? Well, no, that's not true. So is segment AB congruent to segment CD? No, because their distances are not the same. And that's the end of our lesson.